Okay, in this last part of dynamics, we'll be covering some effects of resistive force on motion. And these are the learning outcomes. Okay, we will explain about the effects of friction, as well as describe how motions of bodies with constant mass falling with air resistance looks like. Okay, so before we start, again, let's recap on what we have learned in the previous section. You may pause the video to think about the answer. I'm going to go through the answer now. What are the forces that act on a stationary bus parked in a bus bay? So the bus is stationary, and we know that if it's stationary, there will be zero acceleration. And when there is zero acceleration, there will be zero resultant force. So the only two forces that act on it are the contact force between the bus wheel and the ground, as well as the gravitational force, which is the weight. Everything has weight on Earth. So the correct answer should be C. Okay, next question. Which of the following is accelerating? Okay, the first one, the first option, a car of 500 kg is moving at a constant velocity of 50 kilometers per hour and it experiences an engine force of 5,000 newtons. We know that once we see the word constant velocity, there is zero acceleration, there is zero resultant force. So this is not accelerating, this is zero acceleration. Next, a girl and a boy each pull a toy bear one by one of its arm in the opposite direction, exerting a force of 3 Newton each. So in this case, there are two forces of 3 Newton acting in the opposite direction, and the resultant force on the toy bear will again be zero. So with zero resultant force, it will have zero acceleration again. Next one, a pendulum bob of weight 5 newtons hangs vertically downwards from a retort stand. So the pendulum bob is again at rest. It's hanging from the retort stand. It's not moving. So the object is not accelerating. There is zero acceleration. There is a weight of 5 Newton and there is also a tension force of 5 Newton in the string from the retort stand. So again, this is not accelerating. The correct answer should be D. A car brakes gradually along a rough road. So in this case, the car is moving slower and slower because it's braking. So it is decelerating. So this object actually have an acceleration. It's just that it's negative acceleration. It is decelerating. Okay, so let's move on into what is some of the resistive force. In this particular section, we will only be covering on friction. So we should know that friction is a contact force. It happens between two objects that are rubbing against each other in motion, and friction always opposes the motion. Okay, and then we know that in lower side we have studied that friction can be useful. Friction can also be harmful. So some of the positive effects of friction is it allows us to walk without slipping. It allows a moving object to slow down and eventually stops. But some of the negative effects is it reduces the efficiency of machines and it also causes wear and tear. So how do we reduce the negative impact of friction? There are a few methods. We can use wheels, we can use ball bearings, we can use lubricants, or we can polish the surface to make it smoother, and we can also use an air cushion. All this will help to reduce some of the negative effects of friction. Okay, but obviously there are also some useful effects of friction, and we also use friction to enhance certain effects that we want. So for example, in your car tires, there is this threads on the car tires. We increase the number of threads to increase the friction. And friction on the car tire is very important, especially on rainy days to prevent the vehicle from skiing. Next, we also make use of a lot of air resistance whenever a parachutist is jumping off the aircraft. So whenever you open the parachute, the air resistance increase significantly. So by changing the area of the parachute, we can actually vary the air resistance acting on the parachutist. Okay, and then next we also have rock climbers. Rock climbers need a lot of friction on their hands and on their feet in order to stay attach to the wall and to climb up the wall, to move up the wall. So usually they even use chalk powder to absorb the sweat on their hands, so that their hands, so that it will increase the amount of friction between their hands and the wall. Okay, then we recap a little bit in the previous chapter on kinematics. We have already studied about objects falling without air resistance. We say that if the only force that acts on an object that is in the air is the weight or the gravitational force, we say that the body is in free fall. And we know that if the object is in free fall, the velocity of the object will increase by 10 meters per second every second. We say that the object has a constant acceleration of 10. Okay, so we can see over here, we have a feather and a hammer dropping down. Both of them will drop down at the same speed and at the same rate, which is always 10 meters per second square. Okay, and if we were to plot a graph or velocity time graph for an object falling without air resistance, that means for an object falling only under free fall, we will see that the speed of the velocity of the object will increase by 10 for every 1 second. We will have the gradient of this velocity time graph as the acceleration, and this acceleration will always be equals to 10. The gradient of this graph will always be equals to 10. So it will be a straight line with a constant gradient. Okay, but now let's look at objects falling with air resistance. We know that not every time objects fall, there is no air resistance. In fact, when objects fall from a great height, there will definitely be air resistance acting on it. So with air resistance, the object will not undergo a constant acceleration of 10. But before we move on into looking at the graph or velocity time graph for an object falling with air resistance, let's just understand a little bit about some of the characteristics of air resistance. Okay, you need to know that air resistance is like friction. It opposes the motion. And then you need to know that it increases with the speed. So as you move faster and faster and faster, the amount of air resistance acting on the object also increases. And it increases with surface area and with the density of air. So the question is, if you have an A4 size paper, one piece is flat, that is and is uncrushed, while the other piece you crush it up. Okay, if you were to drop these two pieces of paper, the one that is crushed will actually reach the ground first, because when it is crushed, there is lesser surface area, and with lesser surface area, it will experience lesser air resistance. So the resultant force downwards will be greater on the crushed piece. So the crushed piece will accelerate faster and reach the ground faster. Okay, so this is how a velocity time graph or a speed time graph for an object falling with air resistance looks like. Okay, so this is actually a parachutist jumping down from an aircraft. Okay, so usually questions will ask you to describe this graph in terms of, or describe the motion of the parachutist in terms of the forces acting on the parachutist. And usually, we're not asked to explain the entire section, but mostly from A to B to C. And you need to know at point C, where the speed drops a lot, is when the parachute is open. Okay, so usually A, B, C, D. Okay, let's move on. Okay, so in part A, the parachutist just jumped off the airplane. We say that there is not much air resistance because he just started jumping off. So the only force that acts on him is the weight. So the weight is a constant force. So the only force that acts on him, we say about the individual force that acts on the person. So the individual force is only the weight. And therefore, the second point, we need to talk about the resultant force. So the resultant force is also only the weight, which is a constant. It doesn't change. Okay, so if this man is 400 newtons, as he dropped down of the airplane, he will still remains at 400 newtons. So with constant resultant force, the acceleration will also be constant. So whenever we explain in terms of the individual forces acting on the object, then what happens to the resultant force, and then we link resultant force to the acceleration and then to the motion. Okay, because F equals to ma when the force F is constant, the A will also be constant. So there will be a constant acceleration at the start, which is part A over here. We say that the object is still falling under free fall. Okay, part B, okay, as the parachutist falls, the speed increases. You can see over here, A, it has a constant acceleration. As the speed increases, there is one other force that acts on this parachutist, which is the air resistance. As he falls and falls and falls faster, the amount of air resistance on him also increases. So when the air resistance increases, okay, the resultant force is no longer constant now. Okay, the resultant force, and it's still downwards because the weight is still greater than air resistance, the resultant downwards force will decrease because the air resistance increases. So with the force increase, the acceleration, the resultant force decrease, the acceleration will also decrease. So again, I mentioned about the individual forces, which is the weight and the air resistance. The air resistance is increasing. Then I talk about the resultant force. So the resultant force decreases, and therefore I link it to the acceleration. So the acceleration decreases. So the object is still accelerating. The speed is still increasing, but then it just doesn't increase that much. So we say that it has a decreasing acceleration. So the gradient is decreasing. Okay, and then eventually it will reach a point C. Okay, at point C, it's a very special case whereby the speed of the parachutist is so high such that the amount of air resistance will now be equals to the weight. Okay, and when this happens to the parachutist, okay, the individual forces acting on him is air resistance and weight. Air resistance equals to weight. The second point, you need to measure about resultant force. So the resultant force acting on this parachutist is 0. And then third point, I need to link to acceleration. So with 0 resultant force, there will be 0 acceleration. We say that now the parachutist is moving with a constant speed. And this constant speed is the maximum constant speed that the parachutist can go. He cannot go even faster because the acceleration has stopped at this point. Okay, no more acceleration because resultant force is 0. So this is the maximum constant speed that he can reach, or we also term it as, it is called the terminal velocity of the parachutist. So at point C, he's moving with terminal velocity, which also means constant speed. Acceleration is 0. Okay, let's move on to the next part. So once he has reached terminal velocity, the next step that the parachutist needs to do is he needs to open the parachute. So once he opens the parachute, because of the large surface area of the parachute, okay, the amount of air resistance is now going to increase significantly. So now let's talk about the individual part 1 again. Let's talk about the individual forces on this parachutist. We will know that the air resistance is now much larger than the weight. This is the individual force. Then what happens to the resultant force? The resultant force is now upwards. It's no longer downwards. Okay, but the parachutist is still moving down. Okay, it doesn't mean that the resultant force is up, means the parachutist is moving up. Okay, like what I mentioned in the first part of dynamics, okay, an object will still continue its direction, just that the acceleration and deceleration will change. So now, my resultant force is upwards, or I would say that the resultant force is negative because it's opposite to its motion. Okay, so the second part is this. So with the resultant force being negative, the acceleration, third part, we link it to acceleration. Acceleration will also be negative. But I am not moving up, I am moving down. So with acceleration being negative, it simply means in the downwards direction, it is decelerating. It is accelerating upwards, but it is decelerating downwards. Okay, so at this point of time, you will see it decelerates. Decelerates means that the speed decreases. Okay, then next part, we go into why is it not a constant deceleration, but a decreasing deceleration. This is because as the speed decreases, okay, the amount of air resistance also decreases. So the resultant force decreases. When the resultant force decreases, the deceleration will also decrease. Okay, so it's not a constant deceleration, it's a decreasing deceleration. Okay, and then eventually again, the speed will slow down so much until the air resistance decrease so much until again, air resistance equals to the weight. And again, resultant force is 0, acceleration will be 0. So now it has reached a lower constant speed or constant velocity or a lower terminal velocity now. Okay, so this explains what everything. So remember, every time when we want to explain the motion of certain objects in terms of the forces, I need to see 3 main points for each section of the motion. Okay, the first step, okay, the first main point, you need to identify what are the forces acting on the object at that point. Okay, and then you need to compare it. Is it equal? Is it greater than? Is it smaller than? So for example, air resistance increases, or the driving force is greater than the resistive force, or the weight equals to the air resistance. So you identify these are the forces and you compare the different forces. The second part, we need to say, so what happens with all these individual forces? You definitely need to state about the resultant force. So the forward resultant force decrease, or there is no resultant force, or the resultant force is now negative, upwards, etc. You need to mention about what happens to the resultant force as a result of all these individual force. And the third step, okay, you always link F equals to ma. So with the resultant force given, you can actually compare, you can actually link it to the acceleration. So you need to state the acceleration and therefore the motion in terms of the speed. So with, like for example, if the resultant force decrease, then the acceleration will also decrease, which means that it slows down. Or if the resultant force is 0, then the acceleration will be 0 and it will be moving with a constant speed. Okay, so these are always the 3 points for each section of the motion of the graph that you need to explain. Okay, so again, recap the most important point. You need to know when the object is moving with a constant speed known as the terminal velocity, the air resistance will be equal to weight. Resultant force acting on the object is 0. Okay, so there will be 0 acceleration. Okay, and just take note that if an object only falls through a very short distance, okay, the object may still continue to accelerate and it may not reach the terminal velocity yet because the amount of air resistance does not equal the weight yet if it only falls through a very short distance. Only for objects falling through of a certain height, then it will be able to reach terminal velocity. Okay, let me give you another example. Okay, that you need to know is about terminal velocity for objects of different mass. So you take a look at here, I have a heavier shuttlecock. It has a bigger mass, bigger weight as compared to a smaller shuttlecock or a lighter shuttlecock. Okay, so for the heavier one, it has a bigger weight. So what happens is it will take a longer time for the air resistance to become equals to the weight. Therefore, the speed will still continue to increase more, okay, before the air resistance equals to weight. So it will accelerate longer. So you can see over here the graph, it will continue to accelerate more because my weight is greater. I need more air resistance to become equal to the weight. So I will still continue to increase my speed and at the same time increase my air resistance until I reach terminal velocity. So I reach a higher terminal velocity, and because of the higher terminal velocity, I'm falling with a greater speed, I'll reach the floor faster for a heavier object. But for a lighter object, okay, it is very fast for it to reach air resistance equals to weight because the weight is so small. Okay, I only need to increase the speed by a small amount, then the air resistance will be big enough to be equals to the weight. Okay, so it will reach a terminal velocity at a faster rate. The terminal velocity will also be lower, and therefore it will fall at this constant speed, lower constant speed, and reach the floor slower. Okay, so next question. A parachutist jumps from an aircraft and falls through the air. After some time, the parachute opens. At which point do you think the parachute opens? The answer is D, because once the parachute opens, the amount of air resistance increases significantly. The resultant force becomes negative and the acceleration becomes negative, which means it will start to decelerate. Okay, so at this point, A, B, C is still accelerating. Okay, there is still a resultant force downwards. Only at D, you have a resultant force upwards that causes the deceleration downwards. Okay, you may scan the following QR code to learn more about objects falling with air resistance. That's it. Okay, this is the summary. Okay, we have covered that friction is a contact force that opposes motion and it acts between surface in contact. Okay, and frictions have positive effects and negative effects. We can reduce the negative effects by using things like wheels, ball bearings, lubricants, polished surface, and air cushion. In the absence of air resistance, all objects will fall with a constant acceleration of 10 meters per second, which is called the acceleration due to free fall. But when there is air resistance acting on an object, and when the air resistance equals to the weight, the object will also fall with a constant speed, known as the terminal velocity or the maximum constant velocity. At this point, the object has zero acceleration. That's it.